Good morning, everyone. Can you hear me well? And please put on chat if you can hear me or not. Yes, great. Thank you. All right. Any questions before we start? Okay. So today we are going to basically start learning the techniques which are necessary for the course and the vocabulary that we need. So the first thing first, let's see. Let us recall last time what we call the elementary row operations. These are the operations that going to help us solve the system. All right, what are the elementary row operations? Put on chat what you remember, or just say it. What are the basic elementary row operations? Scaling. Okay, sorry. Scaling, absolutely. It means that you take a matrix, you take a row, multiply it by a constant, and this will become the new row. Other one is replacement. Absolutely. Replacement is the one that you will use the most. It means you take a row, let me call it Ri, and you add it to a constant multiple of another, and that will be the new row Ri. So you replace Ri by the sum of itself and the constant multiple of another. And the second one was, as you guys said, interchange. It means you interchange two rows. So these are the elementary row operation that we will be working with for the rest of the semester. Question number 2, we asked again from last time. We said that A equivalent to B. So what does it mean to say two matrices are row equivalent? Okay, can you just write the definition? So when I say A row equivalent to B, what do I mean by that? Anybody remember the definition? Okay, it means that you can go from A to B by row operation. It means you can start with A, perform some kind of row operation. It means one of those that we stated. Then you can get another one, another row operation, you get B. So A equivalent to B, it means you can go from A to B by performing row operation. And the idea that is if A is the augmented matrix of a system, B is the augmented matrix of another system, both systems will have the exact same solution. Means performing row operation on the augmented matrix does not change the solution of the system. But this notation, again, we'll figure out a lot. We will use a lot. Now, part 2 is definitions. I'll try to go as if I'm going fast, if you guys cannot write, please you let me know. So definition. Leading, suppose we have a matrix A. That's my starting point. A leading entry in a row of a matrix is the first non-zero entry in this row. Okay, so we have a matrix. We're going to see the example immediately. The leading entry in a row is the first non-zero entry in this row. So let us see what I mean by that. So example, put a square around the leading entry in every row of the matrix below. So we're going to take a matrix and we're going to put a square around the leading entry. So the matrix is not important. The entries are not. What's important is the meaning of leading. And 0, 0, 0, 1, and 0, 2, 0, 0. Okay. The leading entry is the first non-zero number. So in the first row, that's what we call the leading entry. in the second row. That's the leading entry, the first non-zero. In the third row, that's the leading entry. And in the last row, that's the leading entry. So leading entry is the first non-zero term in a row. So always talk about leading entry in a row, which is the first non-zero term. Okay. All right. So that's the first definition of today, the leading entry. Part two is, if you guys remember from last lecture, that when I started with a system and then I moved to augmented matrix, and we performed the row operation on the augmented matrix. We did that. And at the end, we had a matrix that looked like this. We had a bunch of numbers that had a zero, bunch of numbers, zero, zero, bunch of numbers. That's what we had when we finished. And when we reached here, we actually look at the system that corresponded to that. So it was z equals something, y plus z equals something, x plus y plus z, and we use back substitution to solve. What we are going to do right now is describe the shape of this matrix, which is, as you realize, the shape of this matrix is some kind of, or like a stair shape. So here we are. Echelon form and abbreviation EF. Echelon, the word echelon, comes from the French word échelle. And échelle means stairs. So we're going to basically describe the stair shape of the matrix. So let's go. Suppose we have a matrix, not necessarily the augmented, just any matrix, an array of numbers. We say that the matrix is in echelon form if the following conditions are satisfied. Okay, the first condition, all the rows that consist only of zeros are at the bottom of the matrix. So the first condition, it should satisfy. It means if we have rows of zeros, they have to be at the bottom. Okay, condition two. Please, if I'm going fast, you cannot write. Feel comfortable to tell me. Okay, condition two. Leading entry, which is the first non-zero entry in a row. Each leading entry of a row should be in a column to the right of the leading entry of the row above it. So what I am talking about. So suppose you have, so this is a matrix, and you have a leading, this is the leading in the second row, and this tells me that every leading entry of a row is in a column to the right of the leading entry in the row above. It means this leading should be to the right of the leading above it. It cannot be to the left. So that's the second condition that's required. Third condition. So please mute yourself. Every student who's not muting himself, please do. Because I don't want to mute the whole class. I want to give you the chance to unmute yourself. 3, all entries in a column below a leading are zeros. It means once you have a leading, everything below it is zeros. So a matrix is said to be in echelon form if those conditions are satisfied. All zeros are at the bottom. Every leading is to the right in a row is to the right of the leading before it. All entries in a column below a leading have to be zero. So let us practice a little bit this definition so we can understand it.
Can you go back to the top of the page for a moment?
Absolutely. Tell me when you're done. Okay?
One moment, please.
Oh, sure.
I'm done.
Thank you. Okay, so let us understand this, this definition. So this is the question here. Describe which of the following matrices is in echelon form. And if you guys have 1, 2, 3 in front of you, you tell me which condition is not satisfied. So the first matrix. Okay. 2, 1, 0, 0, 4, 3. Is this in echelon form? Yes, no. Quickly on chat. And which condition is violated? Absolutely no. Condition 1 doesn't hold. Immediately. I don't have to think, none of them hold, but at least condition 1 is immediately doesn't hold. Okay, because all the rows of zeros have to be at the bottom. Now, another matrix. Again, you guys can write it down and then we discuss it. Is this in echelon form? Also, no, absolutely. So whenever we have a matrix, I'm asking you in echelon form, all of you are correct. Usually we actually start putting square on the leading because this is really help us to understand. That's the leading here, that's the leading here, we're okay, and that's the leading in the third row. So definitely the leading in the third row is not to the right of the leading in the second row. So absolutely no. Condition 2, not satisfied. So this is the staircase situation. That's really, okay. All right. Now, example number 3. Again, you guys can write the matrix down and look at it and tell me if it is or not. Okay, what do you think? Is it in echelon form, yes or not? Okay, nobody's answered. No, again, which condition is not satisfied? 2, okay. Is it 2? Let's see. That's the leading. That's the leading to the right, no problem. That's the leading to the right, no problem. And that's, sorry, my apology. And that's the leading. So which condition is not satisfied? 2, okay, the leading here is not to the right of the leading above it, or who can give me also another reason? 3. Why? Because 3 is important. That's why I'm emphasizing it. What does condition 3 tell us? Everything below a leading has to be 0. Everything below this leading is 0, I'm safe. This is to the right of it. Everything below it is 0, I'm safe. This is to the right of it, but this is not 0. So I would look at this as condition 3 because I want to emphasize this condition. Not such that. Everything below has to be 0. Okay, now this matrix. So now we're going to start building the idea that every time we have a matrix and the question is in echelon form, I'm going to emphasize the leading. Leading, leading, leading. Now, is this in echelon form, yes or not? Okay, please, I'm answering. I'm looking at chat. That's how I am looking at it. Absolutely, it is in echelon form. Condition 1 is satisfied. All the rows, there is no rows of zeros. Condition 2 is satisfied. Every leading is to the right of the leading in the row above it. And condition 3 is, of course, satisfied. Once you have a leading, everything below it is 0. Everything below it is 0, and that's 1. That's absolutely a yes. Okay. And finally, the last one. Again, I'm emphasizing leading, leading, leading. Fairly similar to the previous scenario. Absolutely, yes. So that's what it is for its matrix to be in echelon form. That's basically the shape that it has to be. Okay. Any questions? All right. Part 2 is, can I move the paper? Please tell me yes or no. Now, reduce echelon form. Reduced echelon form. And we usually use REF just to simplify it. So we say that a matrix is in echelon, so a matrix that is in echelon form. So I have a matrix which is already in echelon form. We said is said to be in reduced echelon form if it also satisfies the following condition. So suppose we have a matrix already in echelon form. We say it's in reduced if it has also the extra condition given. Okay, the conditions are, so I'm calling this 4. The leading entry in each non-zero row is 1. So to be in reduced echelon form, we want the leading to be 1. The second condition is each leading is the only non-zero entry in its column. Okay, so we need 2 extra conditions to say it's in reduced echelon form. The leading has to be 1, and the leading is the only non-zero entry in its column. So I'm going to go back to the previous example and analyze this. But I'm giving you a minute to write this down. Okay. Can I move on? Anybody need more time?
Just a minute, Professor.
Sure. Yeah. That's
Thank you.
yeah. Please let me know. So now I want you to look where I keep this here for a little bit more to the examples that I gave previously. And each one of them, you have to tell me whether it's in reduced echelon form or not. Just look at it and then I'll ask you the questions. Ready?
Yes, Professor.
All right, so let me go back to the example that I had before, and let's see which one is in reduced echelon form. First one, it's not in echelon form, so forget it. Second is already not in echelon form, forget it. Not in echelon form, forget it. Now, this one is in echelon form. Is this in reduced echelon form? Yes or not? No, absolutely, because reduced echelon form requires the leading entry to be 1. So not in reduced echelon form. For 2 reasons, actually. Both conditions are violated. First, the leading entries are not 1. It's violated. And also, the other condition is that the leading has to be the only non-zero in its column. And definitely, we have a leading here. It's not the only non-zero one. So definitely not reduced echelon form. This one, we said yes in echelon form. Now, is this in reduced echelon form? Now, why? Yeah, because leading R1, absolutely correct. This is the only non-zero. The second leading is the only non-zero. This I don't care. There is no leading here. This one, it's not the only non-zero because it has a 1 in here. So it's not in echelon form. So this is condition 5. Sorry, not in reduced echelon form. Not in reduced echelon form because 5 is not satisfied. Satisfied. So the only way I can make this in reduced echelon form, I have to change it to making this into a 0. So To make this into reduced, I would need the following matrix: 1, 0, 3, 0, 0, 1, 3, 0, 0, 0, 0, 1. This is now in reduced echelon form. This matrix right here is in reduced echelon form. Okay. All right. Now I'm going to ask you a question just to make sure you understand this concept well, not hard. And okay, I will let you write, and then I will ask you to give me examples. The question is, using the notation, a black box, which is a notation we're going to use frequently, to denote a non-zero number. So when you put a black box my understanding is that whatever you mean by the black box, that's a non-zero number. And a star to denote any number. So star could be 0. Give 3 examples of 4x4 matrices in echelon form with exactly 3 leading entries. So I want you to write this down, and then I want you to give me example. I want 3 of them. So read the question carefully or write it, and then we work with it. Okay, are we ready to start? So I want example. I want 1, 2, 3, 4, 4x4 matrix. It means I want 4 rows and 4 columns. I want exactly 3 leading entries, and I want it to be in echelon form. And the way you will do it, I will do the first example, and you guys will do the other example. So what do I mean by 3 leading? So when I put this, means I mean a non-zero number. 1, 2, 3, any non-zero number. Okay. And if I want this to be in echelon form, and I decide to have a leading here, what should I have below it immediately? Please put on chat your answer quickly. Immediately, bunch of zeros, because I have that. All right, so I have a leading here. I don't care about anything at this stage here because my leading is there. Then I'm going to put a leading right there. So when I put the black square, it means this is a non-zero number. And since this is a leading, to be in echelon form, everything has to be a 0. Now, what about here? What should I have here? Any number. Any number will be represented by a star. So this could be 0, it could be 1, it could be any number. All right, now I want another leading because I want exactly 3 leading. So I'm already took care of row 1, row 2. I'm going to have a leading here. So I'm giving you example number 1. You guys will give me the other examples. Now, if this is a 0, whatever below it has to be a 0. Now, what can I have here? If I want to be echelon form, this should be a star, a black box, or 0. You try to answer me. A star. It could be any number. This could be any number. Now, the 4th column, this column, how could it be? Who can describe this column for me? Remember, I only want 3 leading. I already have 3 leading. So what should I put in the 4th column? What should I have here? Star, 0, decide. Star. What can I have here? Quickly, please. Star. What about here? Star. What about here? 0. Has to be a 0. Okay, so that's really that. It has to be a 0. I cannot have a star because if I have is my star is a number 2, then it will be a leading. That's how to be. Okay, so now I gave you the first example just to give you an idea what I'm looking for. I need 2 more. And the example you have to give me should be different than the one I gave you. It means the location of the leading has to be different. Okay, so who would like to start? And the way you're going to do it, tell me what goes in the first row. second row, third row, fourth row. So that's, I know what you mean. So who would like to give me the first row? No, echelon form. No, that's echelon form. I'm not asking you to reduce echelon form. Otherwise, this would be wrong. All right? Okay, so I want this in echelon form, and I want you to use this notation. So, okay, who's comfortable giving me how the first row would look like? You can unmute yourself to answer, because I think that would be easier.
0, square, star, star.
0, square, star, star. Proceed. Second,
0, 0, square, star.
third row.
All zeros.
Okay, I will write, and then fourth row.
All zeros.
How many leading did I ask for? I want 3 leading. How many leading did you give me?
2.
2. That's not satisfy. I need 1 more leading.
So a square in the dotted 0.
Exactly.
Why could you not do a square at the bottom row of the left
Here.
matrix?
This one.
The one we did before this.
Tell me which row and which column.
In the matrix to the left, all the way to the left.
Yeah.
Why could the last row not be a square there?
Because then I will have 4 leading.
Oh, okay.
I want 3. Okay?
Got it. Thank you.
0. Absolutely correct. I want 1 more example, and this will be the last one. And this will give you a good picture of what we're heading. So another example, again, 1, 2, 3, 4, 1, 2, 3, 4. Okay, get going. Who would like to take over? Again, I want 3 leading.
Square,
Okay, repeat.
square,
Square,
star, star, 0, square, star, star, 0, 0, 0, square,
and the last row. Do
just
we have
zeros.
choices? Absolutely correct. All right, so that's the idea of the echelon form, and that's the idea of the leading entries. Okay, any questions before I move on? All right. Okay, now a theorem that we're gonna basically practice it today. All right. If you take any matrix, regardless how complicated the matrix is, every matrix can be row reduced. What does it mean, row reduced? It means transformed by elementary row operation. It means you can take the matrix, perform row operation on it, and the result will be in echelon form. So every matrix can be row reduced. It means transformed by elementary row operations to a matrix in echelon form. So whichever matrix you start with, you can always play with it by performing row operation, and the end result should be a matrix in echelon form. And today we have to learn the algorithm, basically, of how to do that. Part 2. So the first one tells me that every matrix can be equivalent to a matrix in echelon form. Theorem part 2 tells me, actually, we can do more than that. Every matrix can be row reduced to one and only one matrix in reduced echelon form. Means we start with any matrix, we can not only reduce it to echelon form, we can also reduce it to reduced echelon form. It means I can keep performing row operation on it. So the end result is in reducing echelon form. And I can do that by performing only row operation. One and only one matrix, I will comment on it a little bit later. So it will start making sense to you. And what we are going to do right now is to learn the algorithm. which is algorithm mean the fastest way possible to start from a matrix and make it equivalent to another one in echelon form. So that's what we will be going to do in a minute. I'm waiting just to make sure you guys are done writing. Okay. Can I move on?
Just a minute, Professor.
Yeah, that's okay.
Professor, can you go back to number 1
This one.
on the top? Yeah.
Yeah.
Thank you.
Ready?
Yeah.
Okay.
Thank you.
Sure. All right. Row reduction algorithm. The question is, I have a matrix A, and we want to row reduce it. It means perform row operation on it. So the end result is a matrix in echelon form. So this is the matrix that I'm going to be working with for now to help us learn the algorithm, which is going to be actually not hard at all. We almost have a feeling for it from last time. So remember, I'm going to take this matrix, and at the end, I want something in echelon form. Okay? All right. So this is the matrix. You guys write it down, and together we're going to discuss how we're going to do that. All right. The first step we are going to do, remember, a matrix in echelon form has a leading, and then everything below it has to be 0. So the first issue we're facing here is that I don't have a leading right there. So I want to create a leading in this spot right there. Okay, so the first step is create a leading here. Okay. So which row operation will help me create a leading at this spot right there? I want something which is non-zero here. So how can I do that? We can do it by switching rows, because I have one here, I have two here, I have one here. So the first operation we're going to do is we are going to switch rows. So I'm going to take the row 1 and switch it with row 2. The goal is to create a leading in this spot. Exactly. So let's do that. So 1, so this is going to become 1, 2, 3, 16, and then 0, 1, 4, 18, 2, 1, minus 6, 2, 1, 1, minus 1, minus 2. Okay. That's the first operation. Goal is create a leading one here. Now, I want to go to an echelon form. Obviously, the echelon form said 1. So now I have a leading here. I immediately put a square around it. Leading are very important for us. Now, to be an echelon form, everything below the leading has to be a 0. So my second step is use a row operation to create a 0 right here, and then to create a 0 right there. So how can I create a 0 here? Which row operation I need to do to create a 0? Here I have a 0, I'm safe. To create a 0 right there. So remember, this weekly sign means that those are equivalent matrices. because we're getting them from each other by performing row operation. And I want you to tell me, how can I get a 0? Which row operation will help me to get a 0 here? Replacement, absolutely correct. We're gonna do a replacement. So I'm gonna take replace. We're gonna replace the third row by, since I have a 2, by taking the first one, multiplying it by -2, and adding to the third row. Or, as your classmate said, which is usually is easier for us to write, this will become the new row 3. Okay. All right, so let us proceed. And since I do a lot of stupid computational mistake, I'm gonna use a pencil here. So that's a 1. So I'm not touching the first rows. I'm not touching the second row. But this one is, we have changed. So let us do it. Multiply this by -2 and add it. I have a 0. Multiply this by -2, which give me a -4, and add it. This is going to give me a -3. Multiply this by -2, that's a -6, and -6, that's going to give me -12. Multiply this by -2, that's -32, plus 2, that's -30. And now the last one is 1, 1, -1, -2. Okay, so I'm slowly building my echelon form. All right, so still I have to finish the first column. So I still have a problem here. I want this to I want this to be a 0. So again, I need another row operation. So let's see quickly, how can I get a 0 here? Replacement, very good. And be clear, just to write it the same. So I'm gonna multiply this by -1 because I wanna get rid of this one. So I multiply the first row by minus, add it to the first row, and this will become my new row 4. Very good. So let's do that. Again, I go back to the pencil. So I'm not touching the first row. We're not touch that. We're not touching this one. We're not touching that. And the only one I'm working with is this last one. -1 plus 1, that's a 0. -2 plus 1, that's a -1. -3, -1, that's a -4. -16, -2, that's a -18. Okay, as I said, I tend to do some very simple computational mistake. Just feel comfortable to correct me if I do. Very good. Now I'm done with the first leading. That's a 1. Everything below it is a 0. And then what do we do after that? The way we do it is, remember now I need a leading here. I have a difficulty. We move to the right and then down, right down. And then we try to create a leading in this location. Now I already have a leading, which is great. So I don't have to worry about creating a leading. But now to be an echelon form, everything below it has to be a 0. So now I will use this leading. So I'm done with the first row. I'm going to use this leading to create a 0 here and a 0 right here. So now I'm going to repeat my process that I did a minute ago, but on this submatrix, if you want to call it. All right, so let's see if I made sense to you. Which operation now you want me to do? Okay, which operation you want me to do? Just to write it down or just immute it? Anybody? I would like to get a 0 here. How can I get it easily? So this I cannot touch. That's my leading. I want a 0 here. Replacement, again, I need a replacement. So I have to multiply this. I want to get rid of -3. I want to make this into a 0. So I'm going to multiply this one by 3, the second row by 3, and add it to the third row. So we're taking the second row, multiply the second row by 2, by 3, add it to the third row, that's the replacement, and this is going to become the new row 3. So let's do that. So I'm not touching the first one anymore. I have my leading safe right there. This one I'm not touching. I have my leading, it's safe. It's right there. 0. 3 minus 3 is a 0. 3 times 4, 12, minus 12, that's a 0. 3 times 18. And, okay, what's 3 times 18? So that's going to give me 4, 24, and that's 54. 54 minus 30, that's giving me 14, I guess. 24. Okay, I trust you more than I trust myself. And the last one, 0, minus 1, minus 4, minus 18. Okay, so I have my 1, my leading 1. I have 0 here. Now I need to create a 0 here. So I keep going till I create a 0. So what am I supposed to do? I guess by now everybody guessed it. It's again a replacement. And this is an easy replacement. It's the row 2. I'm going to add it to row 3. And this is going to be, added to row 4. And this will be my new row 4. Okay, so let us proceed. Okay, so the first row, I did not touch it. 2, 3, 16. Second row, 0, 1, 4, 18, 0, 0, 0, 24, 0. Now I add 1 minus 1, it's a 0. 4 minus 4 is a 0. 18 minus 18, it's a 0. Okay, so let's see where we are at now. So I have a leading here, everything below it is 0. This is to the right of it, everything below it is 0. And now, so I guarantee the second column. Now I move to the right and down, right, down. Ask myself, I want to create a leading in this position. Now the question, can I create a leading here? Is that a way to create a non-zero term in here? Yes or no? Is that a way to create a non-leading here? Sorry, is that a way to create a leading here? Absolutely not, because what's below it is a 0, and I cannot interchange anymore. Interchanging at this stage is wrong because I will mess up all my leading. So I cannot create a leading, so I have to move to the right. This is my leading right there. Now I look, is this in echelon form? Yes or not? Is this last matrix? Absolutely yes. So this is in echelon form. I can stop right there. Okay, so let us a little bit repeat how we go from any matrix to echelon form. What is the algorithm? We basically do the following. We move from top to bottom, left to right. So move top to bottom. Okay. From echelon form, from a matrix to the echelon form. Okay, we have to move top to bottom, left to right. And that's the algorithm that we'll be using basically till the end of the semester to go from a matrix to it is echelon form. And as you realize, it's very much based on the idea of how we solve the system by Gauss elimination. That's really how the idea already is coming from. So we create a leading here, then we make everything below it into zero. We move to the right, we create a leading here, and then we make everything below it a zero. And then we try to create a leading, we can't, we move, create a leading here, and we make sure everything below it is a zero. Okay, that's our algorithm for going from a matrix to an echelon form matrix. Part 2 is, suppose I want to go to the reduced echelon form. So I have a matrix, this one, and I perform draw operation to go to the echelon form. My second question is take the same matrix and draw reduce it to reduced echelon form. So let's remember what's the difference between both of them. In the reduced echelon form, or the leading has to be 1. In the reduced echelon form, once I have a leading, it has to be the only non-zero in its column. So part B is the same matrix, it's the same question. Part B is going to be the following. It's the same matrix, so I'm not really changing anything. Question part B is reduce the matrix to reduced echelon form. Okay. How to get it to reduced echelon form? Step number 1 is you put it in echelon form. That's the first step. And now we have to change it. So in reduced echelon form, so the echelon form is the following. I'm going to copy where we got that and use pencil for mistakes. So it was 1, 2, 3, 16. 16, 0, 1, 4, 18. 0, 0, 0, 24, 0, 0, 0, 0. And a habit that I want you to start building up, be careful, always put squares around your leading because they lead you, they tell you exactly what to do. So now remember what we have to do. We want all the leading to be 1, and we want every leading to be the only non-zero in its column. So let us see what's the fastest algorithm to be able to do that. Now, the first step in this problem is, okay, I have 1, 1. I want this to be made into 1. So what should I do as first step? Which operation shall I do? Scaling, absolutely. So I'm going to take the third row divided by 24. And this would be my new row 3. Okay, so the first step in the process is I'm going to make this into 1 because I can. Why not? So again, so this is a 1, a 2, a 3, a 16. It's a 0, it's a 1, and then it's a 0, 0, 0, 1. So as you realize, I'm always putting those here. And finally, 0, 0, and a 0. Okay. Now I want the leading to be the only non-zero leading. What is the fastest way to do it? The fastest way to do it is you start with the bottom leading. So you start with the bottom leading, the one to the far right and to the bottom one. And then we will use this leading to create 0 here and to create 0 in here. So the fastest way to do it is to start from the bottom leading, the one to the right, the bottom to the right, and then use it to create a 0 and a 0 and a row operation. So let's see if you followed what I said. So what do you think is the operation I am planning to do? What do you think the operation I'm planning to do? I want to create a 0 in here. Scaling, why scaling? What do you want me to scale, Thomas? I already skipped replacement. Exactly. We're going to do replacement. So I'm going to take this row, multiply it by, because I want to make this into a 0 using row operation. I multiply the third row by minus 18, added to the second row. So that's the operation. So we're starting from the bottom, top. That's how we go from echelon to reduced echelon. So multiply by minus 18, the third row, multiply by minus 18, added to the second row. And this would create the new row 2 I want. I want to create a 0 right there. So the bottom now, as you realize, I'm going to start writing bottom to top. This I'm not touching. This will not be touched as well. Now, this by minus 18, you see how easy it is. When I multiply this, it's a 0. Multiplied by minus 18, it's a 0. And add it, nothing changed. I multiply this by minus 18, that's a 0, it's a 4. So this is the one that I really want. Minus 18 plus 18 is 0. So I guarantee my first 0 here. So 1, 2, 3, 60. Okay, now I want to create a 0 in here. I'm going to do again another replacement. Replacement is the one you will use most. So this means that I'm creating a matrix which is equivalent to that because we're doing row operation. And so now this is, I'm going to take the third row, times it by minus 16, add it to the first one because that's the 0 I want. And this is going to be my new row 1. That will be the process. So the last row is the same. Nothing have changed. I did not touch it. This one, nothing have changed. I did not touch that one. The second row, the same thing. I'm not doing anything about it. This is the first row that I'm working with. Minus 16 times 0 is a 0, add 1. That's a 0, nothing. 2, that's a 3. And finally, minus 16 plus 16, it is a 0. So I am done with the last column. So from echelon to reduced echelon form, you start basically from the bottom and you start building up. So I guarantee a 1, bunch of 0. Now I move up and to the other leading. This is not a leading. I move to this leading. And now I want to guarantee that this leading is the only non-zero. There is no leading in the third column, so I have nothing to worry about. Then I'm going to move to the leading above it, which is this one. And I want to make everything in this guarantee that there is a 0 above it. I know that there is a 0 already below it because I was in echelon form. I want to guarantee a 0 above it. So the last operation is going to be the following. So I will take the second row. I want a 0 in here, so I have to multiply this by negative 2. So minus 2, row 1, minus 2, row 2, plus row 1, and that would be my new row 1. And that's why I should use a pencil. Okay, so let's do that. So I did not touch the last row. I'm not touching the third row, and that's my leading here. I am not touching the second row as well. It's the first row that I'm working with. So minus 2, that's a 0, so this has to remain. Minus 2 plus 2 is a 0, that's really what my aim is. Minus 2 times 4, it's a minus 8. Minus 8 plus 3, that's a minus 5. Minus 2 times 0, it's a 0, and that's a 0. And now am I in echelon form, reduced echelon form? Leading are ones. Every leading is the only. Definitely that's the reduced echelon form. Okay. So how to go? Let me review the process. If a matrix is in echelon form already, how to go to reduce echelon form? The easiest way, the fastest way to do it is to start with the bottom leading one. You don't start here. You will do more operation if you start here. You start with the bottom leading. You make it into 1 if possible, and then you use it to get zeros above it. Once you're done with that, you move to the leading that came to its left. And then you do the same process. You create a 0 above it, and you keep doing the same thing. So from echelon 4, to reduced echelon 4, you go top to bottom, bottom to top. So you start at the bottom to the top, but right to left. So this is the algorithm to go from there. Okay. Any questions? Right. So now comments about this process. So I did my operation, and a lot of times some student will do something very similar to what I did, but sometimes they will change the row operation. I mean, student will be very creative in doing the row operation. But let's see, like for example, one student, when I asked you to go to the echelon form, probably say, I don't like this 24. So the student will scale it here and put 1. Is this in echelon form? Yeah. Will that be accepted? The answer is yes. So this leads me to the following comment that I would like to make, which is important. Note. So as I said, student may be creative and do different row operation that I did and have make the matrix in echelon form. But let's see what will be in common among all of us. Regardless which row operation we use to get to the echelon form, the position of the leading entry in the echelon form will be the same. And those positions are called pivot position. So you write it down and then I'll explain what I am talking about. So as I said, sometimes students will not do verbatim what I do, which is okay. But however, all of us will have one thing in common at the end. The pivot position, the position of the leading entry will be the same. So what am I talking about? Okay, what I'm talking about is the following. It's very possible that some student, once they reach the 24, they say, I don't like it, I'm gonna scale, make 1. The student is correct, it's still in echelon form. But regardless what we do, all of us will have a leading right there. First row, first column. We'll have a leading here. Second row, second column. We'll have a leading here. Third row, fourth column. Means regardless what you do, the position of the leading will be the same among all of us. Those are called pivot position. Those are called pivot position. So regardless what we do, we will always have the same position. So if I'm giving you a quiz and you guys put me on echelon form, I can immediately know at least that you're right if you have the same pivot position that I had. We all will have the same one. Okay, and those are called the pivot position. Note 2. Pivot column. Suppose you have a matrix A. That's really my original matrix. The pivot columns of A are the columns of A that correspond to the column in echelon form with leading entry, or the column of A with pivot position. So you write it down and then I will explain. Shall I move on and explain it? Are you guys okay? So let me go back to the matrix we worked with. So suppose A, so let's explain this idea. So example, suppose A is the following matrix, the matrix that I worked with a minute ago. 0, 1, 4, 18, 1, 2, 3, 16, and 2, 1, minus 6, 2, 1, 1, minus 1, minus 2. And then when we perform the row operation, I'm gonna only write the echelon form, not the other one, not the reduce. We got 1, 2, 3, 16, 0, 1, 4, 18. And we got 0, 0, 0, 24, or 1. I don't really care which one. 0, 0, 0. All right. So the pivot position, as I said, is this position, that position, and that position. In the original matrix, the pivot are this position, that position, and that position. Now, what are the pivot column of A? They are the columns of A that correspond to the column in the echelon form that has leading. So the pivot column of A are column 1, we call this pivot column, column 2, we call this pivot column, and column 3. Those are the pivot columns. So the pivot column of A are column 1, which means basically eventually we're going to write it this way: 0, 1, 2, 1. Column 2, it means the first following column. And finally, column 4, 8, 16, 2, minus 2. So that's what we mean by pivot column. So they are the column of the matrix that correspond to the column of the echelon form that has leading entry. All right. Another comment, which is also very important. The reduced echelon form, when we are finding the reduced echelon form, as I said a minute ago, one student can stop here at the 24, and one student can scale and tell me 1. Both are correct. The positions are the same among all of us. However, for the reduced echelon form, the reduced echelon form is unique. What does it mean? It means regardless who does it, regardless which operation you do, we all have the exact same reduced echelon form. So the reduced echelon form is unique. It means all of us will have the exact same one. Echelon form is not, the reduced is absolutely yes. So regardless how you do it, we all should end up with exactly same one in reduced echelon form. Now I'm going to ask you just to make sure we understand a little bit the algorithm and ask the following question. So my question is, describe in words the next row operation. So describe, very simple question, in words, the next row operation. So I will give you a matrix. 1, minus 1, 0, 2, 0, 0, 1, 3, 0, 1, 3, 4, 0, 1, 2, 2. So you have this matrix, you want to put in echelon form. Immediately, what's the second row operation? Interchange row 2 and row 3. Okay, I can do that. So because I have my leading here to the right and down. I don't have a leading, I have to create it, we interchange. Zero, 1, 3, 4, 0, 0, 1, 3, 0, 1, 2, 2. Correct. Okay, example number 2. Again, I'm going to give you a matrix and I want you to tell me what's the following row operation. I'm not reducing, I'm just asking you what would you do now? Okay, which row operation you will perform? Anyone? So, of course, as I said, the first thing to do is to mark down your leading. That's my leading here, and that's my leading here. Always we start with that. So what do you want me to perform now? Ideas. Replacement, correct? Tell me which replacement. Exactly. I have to do replacement. I have to take the second row, multiply it by minus square root of 2, and add it to the third row, and this would be my new row 3. That's the only way out. So 1 minus root 2, 2, 3, 0, 1, 2, 4, 0, minus root 2, that's 0. And then, of course, here I will have minus 2 root 2 plus 1. And then I will have minus 4 square root of 2 plus 2. Okay, so that's the only operation. So question, very simple question, but I don't want this mistake to be done. Will this operation be correct? Is this operation correct? I mean, make it 0 here. No, because, Rodriguez, tell me why it's false. So absolutely no. Okay, can you tell us what is false? You can unmute yourself if you can. If you can't, let me know. Why this is absolutely false? Anybody can tell me why this operation is absolutely false? I mean, it may create a 0 here. It will not be a 0 below exactly, because if I do this operation, I would create a 1 right there. So if I do this operation, I'm going to undo something crucial. 0, 1, 2, 4. But then if I multiply this by, I add them, I'm going to create a problem here. I'm going to create a 1 here. Even though I create a 0, but I'm creating a 1 under the leading, which will be absolutely false. Okay, so the only operation is exactly the one that your classmate gave us. Okay, the last question is again along those lines, but now I want to go from echelon to reduced echelon. That's really my idea here. So I will ask you again a simple question. This is my matrix. 0, 1, 4. So my matrix is already in echelon form, and I want to take it to reduced echelon form. Quickly, what is the next step in this process? Remember how we go from echelon to reduced echelon form. So what is the next step in that process? Replacement. Tell me, Haley, what replacement? Tell me exactly, correct? Tell me the replacement you have in mind.
You multiply the third row by -4 and then add it to the
Exactly.
second row.
Multiply the third row because we go from bottom to top, from echelons from bottom to top, plus R2, and that's what will give me the new R2. And that will be 0, 0, 1, 0, 1, minus 4 plus 4 is 0, and then we proceed after that. Okay. So this is the algorithm that, as I told you last time, is basically going to be the only algorithm almost we're going to learn in this class. That's really the only algorithm. And everything we'll be doing is actually we're going to be using it over and over. Next Tuesday, we are going to start using what we've learned today to solve system. And please do your homework for next time. And if you have any questions, usually the way I start the hour is by asking you the questions you have from the homework. Today, it was different. But starting Tuesday, the first thing I will do is, what questions do you have? And we go through your question and then we proceed to the lecture. So definitely, please do the homework. Do not fall behind. Okay, any question before I let you go? Any question? Okay, so goodbye and have a wonderful long weekend. Bye-bye, guys.
Wait, I've got one. When's the first quiz or test?
The first quiz is the day I come back, which is I put it on the syllabus. So
Thank you.
it's going to be quiz 1, quiz 2 at the same time. Usually I never do that, but I have to be in class. So quiz 1, quiz 2 will be together. The first day I come back, check the syllabus. I don't know the date by heart. Okay? So
Okay.
practice. Any other questions? Okay, bye-bye.